to you from Lawrenceburg again, ready to learn our next lesson with Mr.
Lamb
and Mrs. Burger. All right, today's lesson is on learning the real number system. So we have a very particular learning target today. So it says, I can describe and illustrate the relationship among the subsets of the real number system and identify the subsets to which a number belongs.
Which sounds really confusing, and you're going to find out is extremely easy.
That's right. So when we're looking at the real number system, it's right here. Here's a graphic organizer on the real number system.
So really, it's just the way we take all the different kinds of numbers, positive numbers, negative numbers, whole numbers, decimals, fractions, percents, all that stuff,
numbers.
And we just put them into categories where they belong. And I'm going to start with natural numbers. I always like to explain natural numbers as if you have a younger brother or a younger sister or a younger cousin, and you know, like they're like 2 and they're just starting to talk and you're trying to get them to understand numbers, you start with natural numbers. You put a ball in front of them and you go 1. And then eventually they'll parrot you and they'll go 1. And then you put 2 balls in front of them and they put 2. So you get 1, 2, 3. Those are considered the natural numbers.
So natural numbers are kind of like counting numbers,
yes.
Right? You have 1 thing, 2 things, 3 things, 4 things, on and on infinitely to the right of that 0 on the number line, right? Those positive numbers. When we talk about then the next, what we call subset, now we're looking at whole numbers. And whole numbers are all natural numbers, and
we have
now
one more thing.
0. So 0 is a whole number, and then 1, 2, 3, on and on and on infinitely.
And you're going to find a lot of people who are like, well, why didn't they just put 0 in natural numbers? And because one of the reasons is 0 is really a concept that took a long time for people to understand. It's hard to explain nothing to people. When you're like, you can't put a ball in front of your little brother and go, there's nothing there. So if you put nothing in front of them, they still don't understand what nothing is.
Yeah, it's just nothing.
Yeah. Now integers we've already talked about, so we already know these. We know that they're the whole numbers, 0, 1, 2, 3, and their mathematical opposites, -1, -2, -3, and she loves little dots, so I'll keep it going.
Yep, because it goes so on and so on and so on
Yep.
with integers infinitely to the right and infinitely to the left. So those are those tick marks on the number line. When we expand even more, we now have rational numbers. So rational numbers, I like to explain as like rational numbers make sense. They're fractions, decimals, percents, whole numbers, integers, and natural numbers that either terminate, like 1 and 1/2.
Come to an end.
Come to an end.
Terminate. Come
so
to an
like
end.
1.5, right?
Comes to an end.
Comes to an end. Boom, done. There's no like more. Or that have some sort of pattern. So like 1/3 doesn't end. It's that repeating decimal, 3, 3, 3, 3 infinitely. But it has like a pattern to it. It makes sense.
So if you think about it, these are all things that you've known forever. In rational numbers, just take in almost every other number you've ever thought of, right? Because really, you probably never thought much about irrational numbers. Because even from the name of it, irrational means something that doesn't make sense. And so one that I know you will probably know as soon as I say it is pi, right? Pi, which is, we use the number 3.14, but you probably learned in elementary school that pi really goes on forever.
Forever.
Matter of fact, if you put a supercomputer on it and walked away today and came back tomorrow, it'd still be kicking out numbers.
Yeah, but pi really has no pattern and it definitely has no ending.
Yeah.
So pi is the most famous
It never
irrational
ends
number.
and never repeats. It is the most famous of the irrational numbers.
But then we have things like crazy things like the square root of 17. And if we had a calculator up here right now, we would put in for you, but the calculators are so far away right now. But
We're not even going to bother.
But if you put in the square root of 17, it's a kind of mixed number decimal number that just goes on and on and on forever.
And it would just, a lot of those will fill up the calculator. Like,
right.
so however many digits your calculator will go, some go 8, some go 10, some go 12. It will just fill it up and then round the last number.
Right, with no ending and then no pattern to it.
So the thing to know about irrational numbers is they don't, I was going to write not, but they don't end.
Yeah.
and they don't repeat.
And they really have no pattern to them, right? So think about like your mom like kind of yelling at you because you forgot to take out the trash, right? She's like mad you didn't take out the trash, but then all of a sudden she starts throwing in these other things like you didn't make your bed and you didn't do the dishes and
she sounds
you
irrational.
did this, and she's like, and you're like, she's really being irrational. You wouldn't tell her that. You don't tell her she's being irrational.
You definitely don't tell a mom.
Don't tell a mom they're being irrational, but in
your mind,
head,
you're going to use that word.
She's being an irrational number right now. She's not ending, and she has no
and
pattern.
She probably is repeating.
That's true. All right, so let's look at how we identify these subsets that a number belongs in. So this says, what subset of the real number system does -5 belong?
Because here's the key thing that you have to understand about subsets. Numbers can belong to more than one set.
That's true.
Just like the number -5, well, we know it's not natural because those are the counting numbers. We know they're not whole because the only thing different about whole numbers is you add 0.
That's right.
We already know they're integers.
Right, so -5 is an integer.
And it's not only an integer, it's also a rational number because -5 makes sense.
Right.
She owes me $5. That makes a lot of sense.
No, I don't. I owe way more. So -5 belongs to 2 subsets, integers and then rational. What about 0?
Well, again, let's start with natural numbers. We know 0 doesn't work for rational numbers because like we said, natural numbers, because we said natural numbers are what you're going to teach your little brother, and your little brother's not going to understand 0.
That's right.
So, but it is whole. It is an integer.
What is this writing happening?
What's wrong with my writing?
It's irrational.
That's why she does most of the writing. Okay, it is rational because I understand what that means, and so do you. I hope I spelled that right.
That's right, but it's not irrational.
But it's not irrational because we can understand 0.
That's right.
At this age, we can understand 0.
We hope so, right? Especially in pre-algebra.
I might be getting to the age where I don't understand it anymore because I'll be senile.
All right, so moving on from that, we have our last example is now we're going to throw in a fraction.
Yeah. Now, I could never teach you when you were that young what 1/2 meant.
1/2.
Because every time I tried cutting the ball in half, you got mad at me. So it's not. So it is not a natural number.
That's true. It's not a counting number.
Not a whole number.
Not a whole number. It's part of something.
It's definitely not an integer because it has to be whole or its opposite.
That's right.
Which means the first thing it could be would be rational. And I'll let you write it since you make fun of the way I write.
It's a rational number. And that fraction only belongs to one category, right? So a lot of fractions, almost all of the fraction decimals and percents, unless it's a rule breaker, think back to the last video, then would be kind of just in that rational category.
Yep.
Unless it's one of those crazy irrational ones.
So if it's a number that doesn't fit anywhere else, normally they're going to be rational numbers. And then, we don't have the example for it, but don't forget those are rational numbers.
Right.
Those ones that go, if you see ... at the end of the number, we're telling you it doesn't end.
It goes on forever.
So it's irrational.
Unless it's repeating. That's true, like 1/3. All right, so what do we do next? Well, if you're a little confused or you want to kind of refresh your memory again on the real number system, there's a second video that you can watch that's under this video in your assignment. But if you feel like, I'm good to go, I understand the subsets of the real number system, then you're going to move on to the practice portion for today. Don't forget to do the interactive slides that go along with the real number system.
Okay.
All right, talk to you later. Love ya. Bye.
See ya. Bye.